Imagine sitting down to enjoy a plate of crispy French fries. Now think about this. Before those potatoes ever reached your plate, enormous machines weighing more than an elephant fought through mud, rocks, and endless fields to pull every potato from deep beneath the soil. Every harvest season, billions of potatoes travel through these mechanical giants, yet most people never see the incredible engineering behind them. From the outside, a potato harvester looks like nothing more than a slow-moving farm vehicle. But here's what nobody tells you. Hidden inside are hundreds of moving parts working together with split-second precision, carefully lifting delicate potatoes without crushing them. One small mistake can destroy an entire day's harvest worth thousands of dollars. Today, we're going behind the scenes of one of agriculture's greatest engineering achievements. You'll discover where these giant machines begin, why they cost hundreds of thousands of dollars, and how they can harvest acres of potatoes faster than hundreds of workers ever could. And what happens inside the factory might surprise even experienced engineers. Every potato harvesting machine begins long before it reaches a factory floor. Its journey starts in iron ore mines across Australia and Brazil, where massive excavators remove millions of tons of rock every year. Hidden inside that rock lies the steel that will eventually carry machines weighing more than 20 tons across muddy farmland. The ore travels thousands of kilometers by rail and cargo ship before reaching steel mills in Europe, North America, and Asia. Inside blast furnaces, temperatures climb to nearly 1,500 degrees Celsius, hot enough to melt solid iron into glowing rivers of liquid metal. The roar of the furnaces, the heat on your face, and the shower of sparks make it feel like standing beside a volcano. Manufacturers typically use high-strength structural steel with yield strengths exceeding 350 megapascals. This special steel gives the machine enough strength to survive years of vibration, twisting, and heavy impacts while remaining light enough to move efficiently across soft farmland. Most people never think about this balance, but every kilogram matters. Steel isn't the only ingredient. Copper arrives from Chile and Peru for electrical wiring, while aluminum comes from refined bauxite mined in Australia and Guinea. Rubber for the enormous flotation tires begins as natural latex harvested in Southeast Asia before advanced chemical processing transforms it into tires strong enough to support massive loads across wet soil. Hydraulic systems depend on ultra-pure steel cylinders polished to microscopic tolerances. Powerful hydraulic pumps can generate pressures exceeding 250 bar, allowing the harvester to lift heavy digging equipment with remarkable precision. Without hydraulics, these machines simply couldn't survive the brutal demands of harvesting season. Then comes electronics. Hundreds of sensors, GPS antennas, wiring harnesses, cameras, and onboard computers arrive from specialized suppliers around the world. These components transform a powerful machine into an intelligent harvesting system capable of making thousands of adjustments every minute. Before a single bolt enters the factory, parts from more than 20 countries may have traveled over 50,000 kilometers through ships, trains, and trucks. The entire supply chain depends on perfect timing because one delayed shipment can stop production for days. And that's only the beginning, because next we'll step inside the factory where thousands of individual parts become one extraordinary harvesting machine. The factory comes alive the moment giant steel plates arrive at automated CNC cutting stations. Computer-controlled plasma torches race across the metal with incredible precision, slicing through thick steel in seconds. Their plasma arcs can reach temperatures above 20,000 degrees Celsius, producing brilliant showers of sparks while every cut follows digital blueprints accurate to fractions of a millimeter. Freshly cut components move to massive hydraulic press brakes capable of applying more than 400 tons of force. In just a few seconds, perfectly flat steel transforms into strong structural beams that will support the enormous weight of the finished harvester while enduring years of constant vibration and heavy field work. Now comes one of the most spectacular stages in the entire factory. Robotic welding arms surround the growing frame, producing electric arcs that burn at nearly 6,500 degrees Celsius. The air fills with crackling sounds, bright flashes, and the unmistakable smell of hot metal as hundreds of precision welds permanently join the machine together. But here's what nobody tells you. Even the most advanced robots don't perform every weld. Skilled technicians carefully inspect each joint before manually reinforcing critical stress points, because years of experience still recognize tiny imperfections that automated systems can occasionally overlook. Before paint can protect the steel, every frame passes through an aggressive shot-blasting chamber. Millions of tiny steel pellets strike the surface at high speed, removing rust, oil, and microscopic contamination. Within minutes, dull steel emerges perfectly clean and ready for its protective coating. Next comes a transformation that completely changes the machine's appearance. Electrostatic spray guns coat every surface with fine powder before the frame enters curing ovens heated to about 190 degrees Celsius, or 374 degrees Fahrenheit. Minutes later, the once bare steel shines with a flawless, weather-resistant finish. Now assembly begins. Conveyor belts, digging shares, cleaning rollers, hydraulic arms, and heavy-duty axles arrive from different production lines. Workers and automated lifting systems carefully position every component because even a tiny alignment error could damage thousands of potatoes during harvesting. At this point, thousands of individual parts have become one enormous machine. Yet it still can't harvest a single potato. The engine remains silent, the hydraulic pumps stand still, and every sensor waits for its first command. And what happens next is where steel finally comes to life. The machine is finally ready for its heart. A powerful diesel engine, often producing between 500–650 horsepower, is carefully lowered into the chassis using overhead cranes. Every mounting bolt is tightened to an exact torque specification because even the smallest vibration could reduce performance during long harvesting seasons. Next comes the hydraulic system, often called the machine's muscles. High-pressure pumps, capable of generating more than 250 bar or 3,600 psi, connect to dozens of hydraulic cylinders and flexible hoses. As technicians complete each connection, the complex network begins to resemble the circulatory system of a living creature. Now intelligence replaces raw power. Wiring harnesses stretch through every corner of the machine while GPS receivers, cameras, pressure sensors, and digital control modules come online. These systems monitor thousands of signals every second, helping operators harvest more efficiently while protecting delicate potatoes from unnecessary damage. Before the engine ever starts, every electronic system undergoes extensive calibration. Engineers connect powerful diagnostic computers that verify hundreds of sensors, adjust hydraulic pressures, and confirm communication between every control unit. A single failed signal could stop the entire machine before it ever reaches a field. Then comes the moment everyone has been waiting for. The ignition key turns, fuel enters the cylinders, and the massive diesel engine roars to life for the very first time. The entire factory vibrates as conveyor belts, hydraulic pumps, and rotating cleaning systems begin moving together in perfect synchronization. The celebration doesn't last long because every machine must prove itself under pressure. Engineers simulate full operating conditions, checking conveyor speeds, hydraulic flow rates, engine temperatures, and vibration levels. If even one system performs outside its design limits, the machine returns to the workshop for immediate correction. Once factory testing is complete, the machine faces its greatest challenge: a real potato field. Digging blades cut beneath the soil while vibrating webs gently separate dirt, stones, and crop residue from the harvest. Watching thousands of clean potatoes flow through the machine feels less like farming and more like witnessing perfectly choreographed engineering. In just 1 hour, a modern potato harvester can collect several tons of potatoes while performing the work that once required dozens of laborers. But here's the remarkable part. Before any machine earns the trust of farmers around the world, it must survive one final series of inspections that leave absolutely nothing to chance. Building a giant potato harvester is only half the challenge. The real test begins when engineers start searching for flaws that the human eye can barely detect. Imagine spending hundreds of thousands of dollars on a machine that fails during harvest season. That's exactly why quality control inside this factory is so relentless. The first inspection begins with laser scanning technology. High-speed laser sensors sweep across the machine, creating an incredibly accurate three-dimensional digital model. Every frame section is measured against the original computer design, and even a deviation of 0.5 millimeter can trigger a detailed investigation. Next, powerful AI vision systems inspect thousands of bolts, welds, hydraulic connections, and electrical components within minutes. Cameras capture hundreds of high-resolution images while advanced software compares every detail against factory standards. What would take a human inspector several hours happens almost instantly. But cameras alone aren't enough. Ultrasonic testing sends invisible sound waves deep inside critical welds, searching for hidden cracks and air pockets that can't be seen from the surface. A defect smaller than a grain of rice could eventually become a costly structural failure after years of heavy harvesting. The machine now faces one of its toughest challenges: hydraulic pressure testing. Engineers gradually increase system pressure beyond normal operating conditions, often exceeding 250 bar, while carefully watching every hose, seal, and cylinder. Even the smallest leak means immediate repairs before the machine can move forward. Next comes vibration testing. Massive hydraulic platforms shake the entire machine for hours, recreating years of rough field conditions in a controlled environment. Every unusual sound, loose bolt, or unexpected vibration tells engineers exactly where improvements are needed before production continues. Most people assume robots perform every inspection, but here's the surprising truth. Experienced technicians still complete the final visual examination by hand. Years of practical experience allow them to notice tiny paint imperfections, unusual weld textures, or subtle alignment issues that automated systems sometimes overlook. Every successful machine receives detailed documentation proving it meets strict international quality standards. Engineers record hundreds of measurements, inspection reports, and performance results before approving the harvester for delivery. From that moment forward, every important component can be traced throughout its entire working life. Finally, the factory doors open. The completed harvester slowly rolls onto a transport trailer, ready to begin its journey to farms thousands of kilometers away. But the real story is only beginning, because these remarkable machines are transforming agriculture across the entire world in ways most people never imagine. Now imagine this. Every year, farmers harvest well over 370 million metric tons of potatoes around the world, making potatoes one of the planet's most important food crops. Without advanced harvesting machines, collecting this enormous harvest would require millions of additional workers and far more time than modern agriculture can afford. The global market for agricultural harvesting equipment is now worth tens of billions of dollars, and potato harvesters represent one of its most specialized sectors. Manufacturers continue investing in stronger materials, smarter automation, and higher efficiency because every extra potato saved during harvest directly improves a farmer's income. China leads the world in potato production, followed by India, Ukraine, the United States, and Russia. Together, these countries produce a remarkable share of the world's potatoes, each relying on increasingly advanced harvesting technology to meet growing food demand while reducing labor shortages. Here's a surprising fact. The earliest mechanical potato harvesters could only recover a small portion of each crop, leaving many potatoes buried underground. Today's advanced machines routinely recover well over 95% of the harvest, while dramatically reducing bruising and product loss. Did you know that some modern potato harvesters can sort, clean, and gently transfer potatoes without a single person touching the crop? Carefully designed conveyor systems, rollers, and sensors work together to protect every potato from bruising before it reaches storage or processing facilities. Did you know that one large potato harvester can replace the manual work of dozens of laborers while operating for long hours every day during harvest season? GPS guidance, automated steering, and intelligent monitoring systems help operators work with incredible precision, even across enormous fields. And here's one final surprise. Engineers are already developing autonomous harvesting machines capable of working with minimal human intervention. Artificial intelligence, machine vision, and real-time field mapping may soon allow future harvesters to make thousands of intelligent decisions completely on their own. From raw iron ore buried deep beneath the earth to one of the most advanced farming machines ever built, Every step of this journey depends on remarkable engineering and human expertise. Most people only see the potatoes on their dinner plate, but now you know the extraordinary story hidden beneath every harvest. Every bolt, every weld, every sensor, and every moving conveyor exists for one purpose: to harvest food efficiently while protecting one of the world's most important crops. When you look beyond the mud and machinery, you discover an engineering masterpiece designed to feed millions of people every single year. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.